My name is Christos Troussas, and the title of today's lecture is Knowledge Mining from with Artificial Intelligence Methods. Actually, I am assistant professor in the Department of Informatics and Computer Engineering in the University of Statica in Greece. I'm really thrilled to be here in front of you uh, and give this in a topic which is very important in time. Um, Having, let's say, adequate experience in this field, uh, in the field of data analysis and AI, I have the privilege of working on diverse projects in these fields, in domains where the extracting of information plays a crucial role. I have a PhD in informatics and more than 10 years of research. Why? Um, so, artificial intelligence refers to the ability of machines to replicate the knowledge typically associated with human intelligence. Have you ever heard the term artificial intelligence? I know that computer scientists, for sure. The other scientists, of course, so you can understand that AI may encompass various techniques, methods, algorithms that enable machine to learn, plan, and exhibit creativity in problem solving. The key aspect of artificial intelligence is to understand the environment and operate into this towards helping people take decisions. I would like to say that if we receive and analyze all this great amount of data through machines, we can generate meaningful responses and we can take actions. So, one important issue in AI is adaptivity. We mean that AI systems, you can see it here, AI systems can adjust their behavior based on the consequences of previous actions or even historical data. AI techniques, maybe you have heard some of them, deep learning, NLP. I will talk about machine learning in the next slide. We can say that with all these techniques, we can contribute to the development of intelligent systems that can exhibit abilities. Actually, this question is for you. Do you understand why AI is so important to a variety of different fields? Let's say, what about the doctors? Here, of course. So, can you think of something that AI can help you in your field? You have different kind of data. If we think of data of COVID, let's say, now, after 2 years and a half, we have a great variety of different kind of data on COVID. So, can you think of how these algorithms can help you take decisions, change medication, something like that? Or even the social workers, something that many people cannot imagine why AI can help social workers and social scientists. However, we can take decisions, societal decisions, based on the knowledge that we can acquire using AI. So, indeed, AI is very important for many different fields. You can see here, we can use AI in PDA, smartphones, and so on. Houses, for all the people that want to clean their house easily, or online shopping, smart farming, factory robots, many different fields can be helped through the AI techniques. Health. This is for you again. Apart from the utilization of data and to take decisions based on this knowledge coming from data, we can create programs, robots that can help us in an operation. You know it better than me. Transportation as well, or manufacturing sector, you can see that new cars being created in one day. Many years ago, we would like to have more than a month, 2 months, and so on. Food and agriculture. Many farms can use AI systems to monitor the temperature, the feed consumption, and so on, as well as the public administration services. This is an initiative of that takes floor day by day. AI in data. Of course, AI gives us the possibility to process and analyze large amounts of data, so we can take this capacity of AI to handle structured and unstructured data. Do you understand the meaning of structured data or unstructured data? Data that can have a form or data that may not have a form. I'm going to show you some examples. So we want to take this data and transform it into knowledge. So data raw facts, while knowledge is something that is structured and something that can make me understand. Apart from that, AI is used for knowledge mining, knowledge extraction. It's the same thing. We can use methods, different kinds of methods, let's say data visualization, in order to understand how the knowledge can come from data in an efficient way. Because we have the data, we make something and we transform it into knowledge, but knowledge should be in a form that can be easily understood by people. And by understanding the AI for knowledge mining, we can use it in various domains and we can have data-driven decisions. Machine learning. You know it. You have heard of this. Machine learning is a subfield of computer science that has evolved the study of pattern recognition and computational learning theory in AI. The core idea behind the machine learning field is to build models. What kind of models? Models that can generalize from observed data and can allow us to make predictions or extract valuable insights from data. I would like to note here that the field of machine learning may be confused with computational statistics. We have mathematics here, mathematicians, sorry. I would like to note that these fields can be seen together, hand by hand. However, machine learning goes beyond the prediction and focuses generally on the ability to learn from data and adapt, of course, over time. But of course, to make it easy for you, machine learning has strong links and relationships with mathematical optimization, and it provides theories, models, and practical applications for optimizing the performance and efficiency of its technique. Machine learning find application in many different fields, okay, such as AI. Let's say computer vision, which is a field dealing with the enabling of computers to understand and interpret vision. We can take then decision from complex models and data structures. But I would like to say that the application of machine learning is vast and can expand in different and with the aim of revolutionizing the technology and the processing of data. We have two main: supervised and unsupervised learning. Supervised learning can provide, can assist learning using labeled training data and the input with the corresponding output of target valued. On the other hand, unsupervised learning aims to discover hidden, something which is not visible, hidden patterns, hidden relationships with the data, prior knowledge or data. So, if you think of your field, different fields here, can you tell me an example of how supervised or unsupervised learning could be used in your domain? I mean, considering the problems and the open research questions that exist in your fields, in which part would you select to use either supervised or supervised learning? Yes, please. For doctors. It is big data, of course. Let me tell you that unsupervised learning has been used in COVID because in the first times of COVID, we didn't have precise knowledge about which medication could be used. So we would try to find out patterns of hidden information. We didn't know if this medication can work or not. Other ideas? Thank you. Yes, please. Yes, of course. With great success. Exactly. Other ideas or any other option that you would like to pose here? Let me give you other examples in the next slides. Now, examples of supervised learning can include, I'm telling these examples for computer scientists specifically, for email spam filtering, sentiment analysis, fraud detection, image detection, and unsupervised could be used for data mining. An example that we will show here today in a case study of thalassemia. I'm perfect. So, machine learning can be seen in this figure. Okay, we have this figure, and we have unsupervised and supervised techniques used. Feature extraction, we can select, of course, one of them. Then we can select one or multiple machine learning algorithms so that we can have a grouping of objects, a predictive model, or even annotated data. And the new data that can serve as input to the machine, to the system. So we have this cycle working again and again with multiple different results, let's say. So, let's proceed to the basic principles of knowledge mining. What is data mining? Knowledge mining, data mining. There are many definitions. I'm writing here that data mining can be seen as the way to find information or even patterns from large databases using AI, ML, and so on. Or even we can say that data mining is the exploration, the analysis in either an automatic or a semi-automatic way of large amount of data to discover patterns. But why is it important to have data mining? In the era of big data that you said before, if we use traditional ways of manipulating and handling this immense volume of data, the result could not be so good. So if we use data analysis, we can be enabled to effectively analyze and drive insights from this big data. So we would like to apply the algorithms in order to uncover the hidden patterns that there are. And these ways, these algorithms are being used or can empower all kinds of organizations to optimize processes. Let's say a university can use ML to handle different data of students or to advertise its programs. And of course, any other company can do the same. If you are scientists here, I'm researchers, I don't know, probably you can understand that data analysis plays a role in the scientific community and research because it can assist the teams in studying and diagnosing complex phenomena in an easy way. And of course, another example can be the computer and the cache analysis, where data analysis can have the ability to the advertising strategies. So we can see and we can analyze different behaviors, trends, or we can identify possible groups with a set of settings. There is a specific process to follow. This process is a two-way process with many iterative steps and stages. So we have the users. The reason of this two-way process with iterative steps is because users cannot understand or clear picture beforehand the information of interest. So I do not know what kind of information I want, or I don't understand. I know what I want to achieve, I know my goal, but I don't know how to reach this goal. I don't understand the majority of data that I have available. So this is a difficult process, let's say. Apart from that, if I start this process and come to the first conclusions, maybe new questions can arise. And finally, the results of the data analysis did not lead to any useful conclusions with a view to redesigning the process. So we can understand that iteration in this process is because the results cannot be good or new questions can arise and so on. We have data, we have selection, cleaning, not the house, cleaning the data, transform the data, select data mining algorithms, and then have the results. This is a process. And as you can see, I can have feedback and evaluation again and again. I'm going to explain each one of these steps in the next slides. Actually, the main stage is knowledge extraction. The steps that I presented you before is this, but here I have some bullets more. These bullets, the new bullets that can be seen here, is the evaluation of the results, because when I come to a result, I need to assess if the result is good, if the result is bad, and then I can redesign the whole process from scratch. Inadequate database design or improper data collection may result in missing values in the dataset. So, if a person does not offer the possibility of well-structured questionnaire, maybe the database, I mean the place where the data is held, can have a problem. Okay. If I have missing values, there is a challenge for me as a scientist, because they can introduce bias. Or even if there are some mistakes during, let's say, incorrect formatting, again, there is a problem. Or even one question could be, which are the sources where the data come from? All these questions can result into problems. So we need rigorous data cleaning and pre-processing techniques, including data validation or quality checks, so that we can remove inconsistencies. These are some methods for data preparation or data cleaning, let's say. We can have the noise cancellation. Noise can be seen as any value that is not like the values that we know. It's something very, very different. Let's say you're young here, and me, I'm very old. So there is a difference between me and you. This is a noise, okay? Or even we may identify some anomalies, or we need to have algorithms in order to transform or complete some incomplete. There would be a chance of reducing the size of data. Yes, please.
We remove the outliers before the normalization. Oh, okay.
I'm going to talk about outliers for all the participants here.
Noise is not the outlier.
No, outliers is some values very different. I will show you a figure to understand it. This is a noise. This is noise, of course. Same thing. But noise can be some outlier can be seen as noise. Noise includes some other things as well. I'm gonna give you an example of the outliers, and then we will have the time to discuss all these things. So the timing is either predictive methods. We mean methods we predict, make predictions about something, or we have descriptive methods. We mean a way, a structured way, pattern that can describe data and be, of course, interpreted by humans. Some of the tasks can include categorization, clustering, discovery of association rules, successive sub-patterns, and regression. Each one of them will be analyzed in the next slides. The knowledge mining process can be seen here. We have data. This is a data set. We have clustering or association rules or prediction or outlier detection. All these issues that help the knowledge extraction process. Now, here we have a figure showing distances within a cluster. This is the process of clustering. You can see some clusters here, and you can see that the members of each cluster have a small distance between them, while you can understand that members of different clusters have great distance. The distance can be either Euclidean, this is the Euclidean distance, but we can use some other distances as well, let's say the Manhattan. So we have data and we can create clusters of this data. Members of the same cluster can have the same behaviors. If I am a doctor, I can understand that okay, members of the same cluster may be given the same medication or may have the same problems. And of course, some other examples in other fields can arise. But the most important thing is that automatically we can create specific clusters, and the characteristic is the distance between the members of the same cluster or the members of different clusters. One first example that I would like to explain here is the document assembly. So the goal is to find groups of documents that share similarities based on important terms that they contain. So the objective is to organize these documents into clusters, and we need to create a structured representation of the document collection. This is an important process. Probably if you have a PhD, this was the first plan of your step of your PhD. I mean the literature review work and so on. So the approach involves the identification of frequently occurring terms in these documents, and we have to capture the key features that define the content. This is a problem. So in this problem, we need to formulate a similarity measure. This process can allow us to compare the documents. After that, we can apply clustering algorithms. A clustering algorithm is example. Exactly. K-means is one simple example of a great algorithm, of course, but a very easy algorithm that is used for clustering. So if we, let's say, have the k-means algorithm or even hierarchical clustering as well, we can find documents with similar content and we group them in the same cluster. You know, there's an iteration now. We can run the algorithm again and again. Probably new clusters. After some iterations, we will conclude to the last step of our algorithm process, and we can have specific clusters with specific members, and we know that, as I showed you before, of the same clusters share the same characteristics. While members of different clusters have different characteristics. The use of clustering in this process of document assembly leads to improved organization and structured of document collections. We have many research papers in the research community, so we want to have an algorithm, let's say a technique to help us reduce the information overload and can enhance the reading of the algorithms. Another example would be the product promotion. Let's talk about that. What historical data, what data may an organization have concerning its products? Let's say the number of products, other characteristics, You mean how many products have been sold? Something like that? Perfect. Other ideas? What kind of data do we have? Can you think? Whatever. About the product and the organization. You know, the money that the organization can have available to promote. Okay, because everything can be an important characteristic in this process. So you understand that the organization can have many different data, but all this data may not be important for me as a researcher to use them in order to take a decision. I only know the goal. Okay, so the goal, okay, I know it, is to approach the target market I'm sorry, with distinct marketing approaches in order to um, advertise with the best way my new product. So probably here the clustering process can group two things, either the products or the customers. The organization can have information about the products the same organization has or other organizations, and of course, how the customers what the customers did, let's say, in past products, how they reacted to them. So the clustering process can create groups of customers who share common attributes, and this can help the organization understand how to advertise this new product. Okay. We can identify similar customers, and of course, we can identify similar products. I'm creating a product which is similar to a past product that I have, and I know the customers that bought my previous product. So I know that this can be a specific group to whom I will send the emails for advertisement and so on. And of course, I understand what methods or what techniques I can follow because I have the knowledge from previous experience. Apart from clustering, we have something else, classification. Classification, you can see this schema here. We have data. We can have data as customer consumer habits data. We can provide customer or consumer categorization, and then we can sell products to a specific group. In the previous process, I'm in clustering, I created clusters. Now I don't create clusters, I classify. This is the difference. Let me give you an example to understand it. Let's say that the case here is fraud detection. Okay. The objective of this classification process is, in the context of fraud detection, to identify cases of fraud in banking transactions. Perfect. So, my goal is to create a model that can effectively distinguish legitimate transactions and fraudulent transactions. You can understand the difference. We have classification, not clustering. I classify fraudulent, I classify correct transactions. So, can be labeled with a value indicating whether it is categorized as fraudulent or not. So I have a history of transactions, and we create a model to learn the patterns and the relationships to differentiate the fraudulent and the non-fraudulent transactions. So the model in this process here assesses the characteristics of patterns of the new transaction to, let's say, evaluate the likelihood of fraud. The classification here enables the proactive identification of potentially, I would say, fraudulent transactions, allowing them for timely action to mitigate risks and protect customers and so on. Another example, before I go to the example, let me tell you the prediction of cases of fraud in credit card transactions. I mean, how I show the previous example. We have data, transaction. I create the model, and then I proceed to the step of fraud prediction. For the classification, I classify whether one transaction can be fraudulent or not, because I have history data. Here, the second example is the example of sky mapping. This was a work of Fayad in 1996 in the Advances in Knowledge Discovery and Data Mining. The aim of application here is the cataloging of sky mapping in order to predict the category of celestial objects and specifically distinguishing between stars, galaxies, and so on. You can understand how far AI can go in any field. So, think that the data set includes, can you see the number? How many images here? A great number of images, and of course, we have a very high resolution. So we need machines to run all these experiments, okay? So we have the measurement of the image characteristics to be performed, the extracting of relevant information about the objects, and then we can approximately find 40 features to be extracted per object, capturing important details about their sample size, brightness, and so on. And the success story here highlights the remarkable achievement of the model in identifying here, you can see, 16 of the most distant objects, demonstrating the effectiveness of the classification approach. So, in 1996, this was a number which was very high. Now this number is very low, because we talk about how many years? 20. Many years. Okay, so you can understand that now this number is low. At that time, this was a great number. Five minutes only. Perfect. I need to run. Run, Lola, run. Okay. So, I have many things to tell you, so I will proceed quickly. Another technique is the regression. 15. That's better. But I need to run. Okay. Another technique is the regression. In this technique, we can predict the value of given continuous valued variable based on the values of other variable using linear or even non-linear dependence models. I have an example here for price prediction. Let me tell you that the approach is that we have data related to the sales. Then, for these products, we record the cost advertising expenditure, and then we can apply the regression model in order to build a function on the basis of which the prediction of the number of sales in relation to the advertising expenditure can be made. Let me show you visually this process. This process is we have data, we have linear regression modeling here taking place, and then we have the prediction of the prices. I will run, I'm telling this for sure. Let me give you some examples of association rules. Association rules mean that we have specific norms between specific values, and there is a connection between these things, then understand these things have a relationship. Let me tell you that if I buy bread and cola, maybe I will buy milk. This association actually is not something that exists in many people. However, let me tell you that supermarkets use this model. I mean, they see that multiple people may buy bread, Coke, and then milk. This field this rule means that in the same shelf you can find, let's say, cola, milk, and bread. This is obvious. Of course, you can find something very different with something else in the shelf because they analyze these association rules. However, this example here shows what specific customers have bought, and then the rules here says that if a person buys milk, he or she probably can buy cola, or diaper and milk, probably this is a father, diaper for the child, milk for the child, and beer for him. These are the correlation rules. This is just analyzing this. We have some data, we create some rules, and based on these rules, we can have featured products. I'm going to the preparation of data, since I don't have enough time. Let me tell you that the key stages is the cleaning of data. I told you before about the cleaning. Cleaning means that I pre-process missing values, outliers, inconsistent data, and double registration data. You can see here a missing value in the dataset. These are missing values. When I was a student, either I used to erase this field or I put the input here. These are the missing values. I told you about them. This is where you can see a schema here. All the data that we have available, and this datum is this is the outlier. Okay. And consistent data, we observe them in different sources, and we try to merge them in one file. And you understand the double registration. A person, let's say an example, a person registered 2 times. So we have double cases. This is the data transformation process. We transform, we want to transform data in order to convert data from one format to another format. And then I would like to go to the case of thalassemia. Do you know it? Do you know thalassemia? I didn't know it. I knew it now. It's a genetic blood disorder. Am I correct? Of course. Which is characterized by the abnormal production. I'm a doctor, not that doctor. Of hemoglobin, I don't know how you say that, leading to reduced blood cell count and oxygen carrying capacity. Okay, so what we did in this experiment is to describe several variables. So we asked some doctors, tell me, which of these characteristics do you believe that can affect patients of thalassemia? The doctor said this, this, and this. Peak heart rate, exercise, ST segment evaluation, elevation. Perfect. I don't know if they are correct. I analyzed my data. So, I'm going to explain the analysis, but before that, I would like to show you several characteristics. So we have the gender of patients, men and women. We have the age or the type of chest pain. This is the analysis of the characteristics, or even we have the cholesterol levels. 200, 150, 250, and so on. And here we have the correlation matrix. The correlation I don't know if you have seen it before. In the field of diagnosing patients, it is essential to explore potential correlations. I can see the characteristics here. Potential correlations between various variables to gain insights into the relationship that exist among them. So a correlation matrix is a tool that allows us to visualize and analyze all the associations between the different variables. So let me tell you that you can see that some variables can have either a strong positive or not a strong positive correlation. Maybe a strong positive correlation in the field of this thalassemia disease. It can be seen between the hemoglobin levels and the transfusion frequency that would suggest that patients with lower hemoglobin levels require more frequent transfusions. Perfect. I have my doctor here. Making this correlation matrix, I can see and I can have some valuable insights to the diagnostic process. How can I proceed? What can I do? Okay, I know all the historical data. So it is observed that for the diagnosis of patients with thalassemia, we can have three different results. The chest pain by 43%, the pain maximum heart rate by 42%, and the slope of the ST portion of the exercise peak by 35%. Okay, I'm showing you here the same figure, but without the numbers that you saw before, and we identified several correlations in order to detect the risk of factors, okay, and help the healthcare providers take valuable decisions. Here you can understand that the doctors told something, but actually, based on the data that we had available, one thing did not play an important role. So we took into account several variables, let's say the chest pain, the peak heart rate, and so on, and we conclude that these are the variables that play important role for diagnosing the patients with thalassemia. Here you can see the groups that were automatically created here, and see the cholesterol levels and the heartbeat, the max heartbeat. So we have three different clusters. Let's say I'm giving you one example. Cluster 1 includes patients with the lowest cholesterol levels. And now, I'm concluding, we can have a prediction of the model of patient diagnosis. In this last phase, what we do is to use a linear regression prediction model in order to take a decision of this diagnosis. And we found that the prediction model gave a result of 86%. It's good. Look. The accuracy of 86 algorithms I mean, more than 82%, the algorithms can be seen as a good, let's say, result. However, the models, we rely on models and we use them to try to make this 86% even greater and so on. 86% demonstrates effectiveness. However, the most important thing here is that we need refinement and continuous evaluation in order to further enhance the performance and ensure the reliability of the algorithm. In cases specifically of patients' diagnosis, quite important field, we need this percentage to make it even greater. Am I okay with time? Thank you.